Welcome to today's deep dive. We're looking at a really compelling architectural blueprint today.
We really are.
It's a Capstone project.
Mm-hmm.
Specifically, it's Module 8 from the Vibe Code blockchain course. And what makes this worth your time isn't just the code itself, but the mission behind it.
Right.
We're unpacking how to build a real-world full-stack application that's designed to solve a massive global problem. I mean, we're talking about international money transfers here.
Yeah, the cross-border payment issue.
Exactly. And we'll be exploring how you can leverage an AI-assisted development workflow, what the course actually terms vibe coding.
Vibe coding, right.
Yeah. To take a process that historically takes days and reduce it to a sub-penny transaction that settles in 5 seconds.
It's an incredible shift. For you listening, this is a rigorous culmination of an entire learning journey. We are moving entirely beyond theoretical cryptography here and looking at applied blockchain architecture. This capstone forces you to connect the raw backend logic of smart contracts with a tangible front-end user experience. And we're addressing a deeply entrenched global friction point in the process, connecting the dots between raw tech and real human impact.
And to understand the architecture, we first have to frame the friction it's trying to resolve. Because we're looking at an $800 billion annual market.
It's huge.
$800 billion in cross-border remittances. This is capital flowing primarily from migrant workers back to their home countries.
If we connect this to the bigger picture, the sheer scale of that capital flow highlights the inefficiencies of legacy infrastructure.
Right.
The traditional remittance rails, your standard wire transfers or services like Western Union, they're burdened by fragmented liquidity pools.
And correspondent banking networks.
Exactly. And geographical silos. I mean, every intermediary requires a cut to manage their own ledger, and every single border crossing introduces latency.
Which is quantified in a typical 5 to 10% fee structure.
Yeah.
Not to mention the 2 to 5 days of waiting. Just settlement latency. So when you look at the latency and cost metrics of the Stellar solution built in this module.
The alternative.
Right, the alternative, 5 seconds.
Yeah.
And sub-penny settlement. It completely reframes what we consider acceptable for cross-border transit.
It really does.
But before we get into the decentralized exchange mechanics, I want to look at the methodology they use to actually build this application, because the module leans heavily into this concept of vibe coding.
It's a fascinating paradigm shift in how we approach development. Vibe coding is presented essentially as a 4-step meta skill.
Describe, understand, verify, and iterate.
Right. You're using an AI agent, in this case Claude Code, to generate the foundational boilerplate and logical structures based purely on plain English prompts.
But I guess my question is, if we're relying on an AI like Claude to vibe code financial logic, how do we ensure it doesn't just hallucinate a vulnerability in something as sensitive as a cross-border payment?
That's the main concern, isn't it?
Because delegating the architecture of an app, handling real value, seems inherently risky if you aren't inspecting every single line yourself.
This raises an important question, and it's exactly why the understand and verify steps of that 4-step process are completely non-negotiable.
Okay.
The module makes it clear that vibe coding is not about blindly copying and pasting. The AI is a co-pilot. It's not an autonomous lead developer.
Right.
Your role as the developer shifts from memorizing syntax to acting as an auditor and a systems architect. You have to read the generated code, understand the state changes, and mathematically verify the security logic.
So the tools might change, but this meta skill is the real takeaway here.
Exactly. The frameworks will inevitably change over time, but this mindset of directing, auditing, and iterating, that is the core competency you need to tackle any new blockchain ecosystem.
That makes total sense.
Yeah.
It shifts the cognitive load from syntax generation directly to system design.
Exactly.
And the stack they spin up using this workflow is, it's highly efficient.
Very modern.
Yeah. Through these prompts, they initialize a React Invite project for a lightweight front end. They use Tailwind CSS for utility-first styling.
Nice and fast.
Right. And then they integrate the Freighter wallet for secure user key management and pull in the Stellar SDK to handle the actual ledger interactions.
If you've built modern web apps, this stack feels incredibly familiar, which lowers the barrier to entry significantly.
Totally.
You aren't wrestling with esoteric languages just to render a button, but the UI is ultimately just a shell.
Yeah.
The real gravity of this application lies in how it navigates the complexities of global liquidity routing under the hood.
Okay, let's unpack this. Because the exchange rate handling is where the application logic gets really sophisticated. In a global remittance app, you need live, highly accurate pricing.
You do.
So the vibe coding prompts guide the developer to create a specific React hook called useExchangeRate. And this hook is designed to ping the Stellar decentralized exchange, the DEX, every 10 seconds.
Just constantly polling.
Right, fetching the absolute latest conversion rate between an input asset, like USDC, and a target fiat token.
And that continuous polling of the DEX is critical because it feeds directly into the network's path payment operations.
This is the magic part.
It is. Specifically, the architecture utilizes Horizon's strict send paths and strict send payment endpoints. This is the engine of that 5-second settlement.
I want to dig into the routing logic there, because in a legacy system, moving from US dollars to the Brazilian real, the BRL, that often requires hopping through an intermediate fiat currency.
Oh, yeah.
Which means multiple ledger updates and honestly multiple fee extractions along the way.
Precisely. But with a path payment on Stellar, that routing happens algorithmically at the protocol level.
So in a single step.
Yes.
Yeah.
Think of it like walking into a busy European airport with US dollars.
Okay.
By the time you reach the cashier to buy a coffee, your dollars have automatically transformed into euros at the absolute best possible market rate.
Without you having to do anything.
Right, without you ever having to locate a currency exchange booth or negotiate a spread.
So the sender simply inputs USDC, and the network automatically traverses the various order books on the DEX to output BRL on the recipient's end.
Yes.
It might route USDC to XLM and then XLM to BRL, all within a single ledger close.
Exactly. It evaluates multiple liquidity pools simultaneously to find the most efficient path. The sender hits execute, and the conversion is an atomic single-step operation.
It's seamless.
From a UX perspective, the complexity of order books and liquidity fragmentation is completely abstracted away. The user just sees the input and the final output.
But abstracting that complexity doesn't remove the underlying market mechanics.
No.
The market is constantly moving. So if we have a 10-second polling window on that useExchangeRate hook, what happens if the DX liquidity shifts abruptly? Like right between the moment the UI estimates the transfer and the exact millisecond the user signs the transaction.
That is the danger of slippage. And it's a critical vulnerability when you're building financial infrastructure.
Because if someone is sending a critical remittance,
they cannot afford for the recipient to receive 5% less than expected just because a large trade temporarily drained a liquidity pool on the DX.
So how does the Capstone architect a defense against that?
The defense mechanism is built directly into the transaction payload. They use a parameter called destination minimum.
Okay.
The application calculates the expected receive amount and multiplies it by 0.99.
Oh, I see. So it programmatically enforces a strict 1% slippage buffer.
Correct. You are cryptographically binding the transaction to that condition.
Oh.
You're telling the Stellar network nodes, if the recipient's account does not receive this exact minimum threshold, revert the entire operation.
It fails safely.
It fails safely. It refuses to execute a disadvantageous trade, entirely protecting the user's principal value.
That is a vital piece of consumer protection, and it's really just one component of a much broader security posture they apply to this application. The module actively pulls in the rigorous security audit checklist from Module 7 to harden this vibe-coded baseline. For example, they mandate a pending.setTimeout30 to the transaction builder. Why specifically 30 seconds?
Well, when you submit a transaction to a decentralized network, you're broadcasting it to the mempool, hoping a validator includes it in the next ledger close.
Right.
If there's a sudden spike in network congestion, or if the fee you offered is too low, that transaction could theoretically sit in a pending state indefinitely.
Which is terrible UX.
In the context of remittances, a hanging transaction is disastrous. The user doesn't know if they should send it again or wait.
Because if they send it again, they risk double spending their own funds once the network clears.
Exactly. By enforcing a 30-second timeout, you guarantee finality.
It either works or it doesn't.
Yes. The user gets a definitive success or failure state almost immediately, which allows the application to render the appropriate next steps in the UI without any ambiguity.
Certainty is paramount. The audit also enforces standard operational security, verifying that no secret keys are ever cached or stored in the front-end components.
Which sounds obvious.
That sounds obvious, but it is a frequent failure point in early dApps.
Oh, absolutely.
Furthermore, they utilize strike key validation, Before the application even constructs the transaction, it mathematically verifies that the recipient's public key is formatted correctly for the Stellar network.
Which prevents a user from irrevocably burning their capital by pasting an incomplete address or an address meant for an entirely different blockchain.
Yeah, you don't want to send USDC into the void.
No. And equally critical to security is how the application handles errors. The audit requires mapping raw Horizon error codes into human-readable, actionable UI messages.
Right, because if a transaction fails due to insufficient trust lines or a depleted sequence number,
Throwing a raw JSON error object at a non-technical user completely shatters their trust in the platform.
yeah, it looks like it's broken. You have to translate protocol-level state failures into simple instructions. Something like the recipient needs to authorize this asset.
Exactly.
Now, here's where it gets really interesting. Building a secure transit layer is one thing, but Module 8 introduces complex programmable logic on top of it. The Soroban escrow.
Yes, the escrow integration is where the architecture becomes truly sophisticated. Escrow traditionally requires an expensive legal intermediary to hold funds until conditions are met.
But Soroban lets you bypass that.
Soroban allows you to codify that trust.
So let's trace the flow of this. In the app, a user toggles on an escrow mode before sending. They designate the public key of an arbiter, a trusted third party.
Right.
When the transaction fires, the USDC doesn't go to the recipient's wallet. It gets locked inside a deployed Soroban smart contract.
What's fascinating here is the state management. The smart contract now holds the cryptographic custody of those funds.
Okay.
It contains explicit logic stating that only the digital signature of the designated arbiter can trigger the next state change,
Which is either releasing the funds to the recipient.
or reverting them back to the sender.
But what are the edge cases? I mean, what if the arbiter loses their private keys or simply goes offline indefinitely? Are those funds just permanently locked in the contract?
That's a great question. That's where you have to engineer fallback mechanisms within the Rust code of the smart contract itself,
Like time locks.
like time locks. You can program the contract so that if the arbiter fails to provide a signature within, say, 72 hours, the sender can unilaterally call a function to reclaim their initial deposit.
Wow.
It's about building trust-minimized agreements. This feature beautifully synthesizes the entire course curriculum. It fuses the back-end computational power of Module 5's Soroban contracts with the accessible front-end patterns developed in Module 6.
It proves that you can bypass traditional escrow services using just a few dozen lines of audited Rust code.
It really does.
And to make that complex back-end feel responsive, the front-end engineering is incredibly sharp.
Yeah, they didn't skimp on the UX.
Not at all. Instead of relying on traditional REST API polling, where the client constantly asks the server, "Are we there yet?" the application utilizes Horizon SSE, or server-sent events.
SSE is a highly elegant architectural choice for blockchain interfaces.
How so?
Well, instead of the client polling, which drains resources and creates artificial latency, SSE establishes a persistent unidirectional connection.
So it's always listening.
Right. The Horizon server simply pushes real-time ledger updates directly to the browser the millisecond a transaction is confirmed.
Which powers this fantastic UI feature. The application streams the last 20 transactions live on the screen.
Yeah, that's a great touch.
When a new transaction hits the ledger, the UI instantly triggers this really satisfying green flash animation.
Yes.
And they format the path payments so cleanly. The user sees a single row that reads, "Sent 100 USDC to received 500 BRL." It takes the abstract, invisible nature of cryptographic state changes and makes it feel tangible.
That visual feedback loop is how you build user confidence. When you see that green flash, you intrinsically trust the system. Definitely.
But we have to acknowledge that having a responsive, secure application running locally or on a test network is really only the halfway point.
Which brings us to the deployment arc. Taking this application live, moving it into production. The course outlines a dual deployment strategy.
Right.
For the front-end interface, they utilize Vercel, which provides incredible speed, global CDN distribution, and CI/CD pipelines out of the box.
Vercel is standard for modern web apps. But if your goal is true decentralization and censorship resistance, relying on a single corporate server infrastructure is a single point of failure.
It defeats the purpose a bit.
It does. That's why the module also guides the developer to deploy the front end to IPFS, the interplanetary file system, via PNADA.
Okay, so by pinning the front end to IPFS, the application logic is distributed across a peer-to-peer network.
Exactly. It aligns the resilience of the front end with the resilience of the blockchain itself.
But the real friction in deployment isn't hosting the front end. It's transitioning the back-end infrastructure from the sandbox to the real world, moving from the testnet to the mainnet. Oh, absolutely. If you've ever deployed a decentralized application, you know that the transition to mainnet is where poorly architected projects collapse.
Because the stakes are real?
The testnet is a forgiving sandbox with valueless tokens. The mainnet is immutable and adversarial.
So what does this Capstone's mainnet checklist actually require a developer to do?
It requires a deeply methodical scrub of the entire code base. You have to locate and strip out any hard-coded testnet public keys or test contract IDs.
Right.
You must rigorously update your environment variables so the application points to the live public horizon nodes rather than the testnet nodes.
You also have to update the UI, removing those yellow testnet warning badges so users know they are interacting with real value.
Crucial step.
You have to test against real asset codes because testnet assets don't behave identically to live ones.
No, they don't.
And crucial to what we discussed earlier, you have to validate that your 1% DESmin slippage tolerance actually holds up against the volatility and liquidity depth of live DEX order books.
Exactly. You have to test it in the real world. But even if your code is flawless, your smart contracts are audited and your deployment is perfectly executed.
There's still a missing piece.
A remittance application is entirely useless if the recipient can't actually buy groceries with the digital tokens they received. You need a bridge to the legacy financial system.
And this is where the module introduces a critical architectural concept for the Stellar ecosystem. Anchors.
Anchors, yes.
What role does an anchor play in bridging this pristine digital environment with messy real-world fiat?
An anchor is a licensed real-world financial institution that integrates with the Stellar network. They act as the designated on-ramps and off-ramps.
Okay.
While your vibe-coded application handles the instantaneous sub-penny transit of value across the globe, the anchor handles the regulatory compliance, the KYC checks, and the actual bank transfers.
So, to make this application fully functional for an everyday user in Brazil, as a developer, you would need to integrate your front end with an Anchor's API.
Yep.
The user submits their local banking details through your UI. The smart contract routes the USDC, converts it to a digital BRL token via the path payment, and delivers it to the anchor.
And then the anchor steps in.
Right. The anchor then burns that digital token and wire transfers the equivalent fiat directly into the user's local bank account.
Precisely. The blockchain serves purely as the highly efficient transit layer. The anchor serves as the settlement layer into the traditional economy.
That makes a lot of sense.
Understanding how to interface with those anchors is the final essential step in moving from a clever code base to a disruptive financial product.
So what does this all mean for you, the developer, or the technologist listening to this? Let's zoom out and look at the trajectory we've tracked today.
Okay.
We started with an $800 billion global inefficiency, a remittance system that heavily taxes the individuals who can least afford it.
Yeah.
We examined how this Capstone project provides a blueprint to solve that by building a secure, escrow-enabled application that leverages path payments to settle cross-border transfers in seconds.
And we explored how that complex architecture can be rapidly prototyped and refined using an AI-assisted workflow, provided, of course, the developer maintains strict oversight of the security logic and state management.
I think the ultimate takeaway here is recognizing the power of that vibe coding meta skill, the specific syntax of the React hooks or the Stellar SDK. It's eventually going to become outdated.
Inevitably.
But the ability to systematically describe a complex financial problem, understand the generated algorithmic solutions, rigorously verify the cryptographic safety, and deploy it across distributed networks, that is how you remain resilient and dangerous in a constantly evolving tech landscape.
That mindset is absolutely the most durable skill you can develop, and it leaves us with something quite significant to consider regarding the broader macroeconomic landscape.
What's that?
Well, if a single developer, utilizing modern AI workflows and open-source blockchain SDKs, can architect and deploy a decentralized application that routes global capital in 5 seconds for a fraction of a cent, how long can traditional financial institutions justify their 5% fees and multi-day settlement delays?
That's the real question.
The barrier to engineering superior financial infrastructure has effectively fallen to zero. It's no longer a question of if legacy systems will be replaced, but how quickly.
If the traditional systems refuse to adapt their architecture, the open source developers are simply going to route around them.
Exactly.
Thank you for joining us on this deep dive into Module 8. We hope examining this blueprint gave you some new frameworks for your own projects. Keep building, stay curious, and we will catch you on the next deep dive.